what we're going to do is we're going to take probably about every third day, I'm going to do a topic that is a question that has been asked on a Calc 1 exam to eliminate A's from the courses. Okay? That's what this really is. This is Calc 1 questions. Now, how many of you in here will be taking Calc 1 next year?
I don't know.
You will be. If you're majoring in anything at the school you're discussing, you will be taking Calc 1. Miss, where are you going next year?
LSU.
What are you majoring in?
Kinesiology.
You'll be taking Calc 1. Yeah. But yeah, unless you're a history major,
English
sociology major, and English major, you'll be taking Calc 1. Now, so, here we go. And what I'm going to do is try to cover the questions that cause people to not get their A in their Calc 1 class. And one of the first questions, the question that's at the end of all the limits exams, if you have a test just on limits, is right there. Prove that limit. Now, your professor may have proved it in class, or he may have just assumed you were going to read the proof in the book. But that's the first question. How do you prove that? So here we go. And, and then I'm going to do a couple on derivatives, some proofs for derivatives. Because usually those are the hard questions for students, how do I prove something? All right. I would hope that you would write these down, since everyone in here will probably need them. First thing you do, if you're going to prove this, it helps to have seen it before. This is your opportunity. You need 3 drawings to prove it. It takes 3 drawings from your unit circle to prove it, and that's what I'm going to try to help you get started. When you do proofs in college, do not try to memorize the whole proof. You've got to know how to start the proof and then work from there. X squared plus y squared equals 1. And we're just going to look at the first quadrant of the unit circle. And you'll need 3 of them. So I'll just go ahead and put the 3 of them up here. If you were seeing this in a college classroom, they would probably just use 1 drawing and just put it all on 1 drawing, which works great, except then it's hard for you to see the parts. So that I can spend some time with it and actually teach, not just scribble, I'm going to let you do 3 little unit circles and line them up across the page, because or line them up down the page. You can go here, 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 and put one under the other one, and then have room beside it to write. That might be better. Put like this one and leave a bunch of room over here to write. Put this one, have a bunch of room over here to write, and run them down the page. But that's what you need. You need 3 of them, Mr. Shaw. Write, draw, write.
Mr. Evans.
It's going to be worth 1,000 points when I look at your paper at the end of the hour. Yes, ma'am.
When you say in a college class they may only have 1 drawing,
It'll have all 3 of these on top of each other.
Yeah, but when they expect you to prove something like this, will they have shown you it before or no?
Maybe not.
Okay.
I'm not. Yeah, maybe not. It may be that it was in the book and they said, hey, there's a really cool proof for this in your text that you may want to look at, and then all of a sudden it appears on your first test.
Okay.
They're deciding who deserves an A and who gets a B.
They'll notify you in some way that you need to know it?
No, not necessarily. Sometimes it's just, usually they do mention it, but sometimes they're just, there it is. Okay? Now, the first thing you want to do is you're going to do 3 triangles. And we're going to put our triangle here. We're going to mark theta here. And theta is going to get smaller. So what's going to happen is this line that's going out to the edge of our unit circle is going to drop down, drop down, drop down, drop down. Fair enough? Now, I'm going to draw the triangle so that I have a right triangle right here. If your professor in college were to do this on the board, and he draws the line from here to here and makes a triangle where it's not a right triangle, this would be the height of the triangle, but then the base would be 1. Don't tell him he's wrong. It still works. Okay? The triangle has to be inside of this arc of the circle. Okay? It's got to be inside of that arc of the circle. That's where the triangle has to be. Now, what we're going to do is I want to look, if you can tell me, now remember, what's the radius of the unit circle? What's the radius? 1. So we know this side over here is 1, because it's the hypotenuse, right? I want you to tell me the area of that triangle right there in terms of theta. What is the area of that triangle? This is a 1,000-point assignment, so start writing.
I'm ready.
I will look at yours at the end of the hour.
All right. Something.
Now, 1,000 points. That way you can't get an A in here. All right. Does anyone want to help me out on this? This is where you have to do the thinking. What goes in those blanks? What is, okay, the base is what? From here to here, right? What do you know about the x and y values in terms of theta right here? What is the x value right there equal to in terms of theta? Unit circle? Cosine of theta. What's the y value right there according to your unit circle? Sine theta. Notice we're going back and talking about the unit circle there. You got the unit circle. Now, if that's the y value, that's sine of theta, right? Okay? And if that's the x value, then the x value measures from here out to here, right? X measures there. So there's your x. So what does x equal?
Cosine
And x is the what? Base of your triangle. Is everybody all right with that? Okay. So cosine theta is the base of your triangle. And what is the height of your triangle? Sine theta. And we've got all this information before we ever knew any calculus, because all that came off of your unit circle. Okay. Now, let's look at the second little drawing. We'll do this one. What we're going to do, and on this one's hard, because we're going to talk about the area of this arc, this little piece of pie. We'll talk about the area of that arc. Here we talked about the area of this triangle here. We're finding the area of this. Now, what we're going to do is we're going to find the area of this green region. Now, for the area of that region, there is a formula for the area of the arc of a circle. Does anyone know that formula? Make me feel good. You at least got sine and cosine out of the last bunch. Someone tell me, what is the formula for the area of the arc of a circle?
Radians over 2 radius squared.
Radians over 2 times the radius squared. Thank you. I was hoping someone knew that one. That's one of those ones that y'all don't really put in long-term memory that you should. Now, if you want some help remembering it, how far do you go if you go all the way around the circle? You go how many radians?
2.
2 pi. And if you divide 2 pi by 2, you get what? Pi. And the area of a circle is what? Pi r squared. So you're taking the radian measure if you go all the way around the circle, and you're dividing it by what? 2. So that helps you. If you know pi r squared, then you know that really you went 2 pi to go all the way around the circle. Area of a circle equals 2 pi divided by 2 r squared. Well, there's your 2 pi divided by 2. Radians divided by 2. Now, the good news is, since this is a unit circle, we know what the radius is. What is the radius? 1. And the radian value is whatever this angle is. Fair enough? It's really the length of that right there. Okay, so we get theta over 2. is the area of that green section. Now, Mr. Shaw is going to wake up and be ready for the third question. Here we go. This is a chance to impress me. Miss Quarles, how you doing so far? Happy with it so far? See, because I care about you and doing well. All right, now I'm going to take this and I'm going to go through the edge of the circle, and I'm going to come down and I'm going to make my right angle right where it's tangent to the circle at the x-axis. And I'm going to put my theta here. And ladies and gentlemen, we're going to talk about what is the area of this triangle. And what is the formula for area of a triangle?
1/2 base times
1/2 base times height. And I'm going to be really nice. So I'm going to tell you the base equals 1. From here to here is 1. Does everybody agree from here to here is 1? Okay? I want to know what the height of the triangle is in terms of theta.
Sine theta.
Sine theta. Well, let's see. There's the height, right? If you did sine theta,
Or that would have given you just
the h over the hypotenuse, that h over the hypotenuse, but I don't know the hypotenuse anymore, do I? Okay? Help me out. Who said tangent? Be brave, you might be right. Mr. Shaw, why did she say tangent?
It's
You know what
the opposite, and then if it's just over one, then it's itself.
Tangent theta equals the h, the height, over 1,
Yes.
because we know that side is 1. So the height of that triangle is the tangent of theta. Thank you, Mr. Shaw. You're giving me hope.
You're welcome.
Thank you, Miss Quarles. You weren't brave enough, Miss Quarles. Speak up and be brave. All right. Now, as theta gets really small, look at the area of that triangle. Look at the area of that sector as theta gets really small, and then look at the area of this big triangle here at the end as it gets smaller. At the very beginning, what is the relationship between the area of this triangle, this triangle, this triangle? And that is going to stay true all the way down until theta gets to 0. When theta gets to 0, they're actually going to all have the same area, right? But what's going to happen along the way? What's true about the areas along the way?
As theta decreases, the area of all of them decreases.
They all decrease, and what's the relationship between all three of them?
similar.
That is less than that. Is less than that.
This one is less than this one, which is what?
Less than that.
Less than that one. And you could throw an equal to sign in there for when they do what? Go all the way down to 0. I don't usually throw the equal to signs in there, and you don't really have to have them, but there they are. But what we have a relationship that involves these three triangles. Now, the first person to come up with this didn't come up with it in a day. All right? It probably took them a while because they came up with this relationship. And this relationship goes where they need it to go. So they probably came up with a bunch of different pictures that didn't actually work. All right, here we go. And the problem is, how many of you have that really nice and pretty in your notes? And you know that one's less than that one, which is less than that one. So if you were trying to prove this for your exam and you knew it was going to be on your exam, you would want to be able to draw these three triangles. And this is always the hard one right here, is getting the height of this one. And that's always the one that gives students trouble when you present it in class. And that's the one that they just put a big question mark when they do their proof. All right, I have to erase this because what I want to do is write the three equations. So we have 1/2 sine theta cosine theta. We'll change the order of that. Less than or equal to theta over 2. Put this one down. See, I'm getting a chance to teach today, you're getting a chance to learn here at the end of the year without having to do a whole lot of work. And then 1/2 sine theta over cosine theta. Mr. Evans admits the weakness there of not wanting to do tangent theta. What could I do to make all these look prettier? Just multiply everything by 2. Yeah, make them look pretty. Multiply everything by 2. Is that going to change anything about these right here? No. So you're going to get sine theta, cosine theta, less than or equal to theta, less than or equal to sine theta over cosine theta. Cosine theta. Now, I'm going to tell you the next step, and I'm going to ask you why. But I'll tell you what I'm going to do on the next step. There's 2 options. So, and they're all right because you're doing a proof. But what I want to tell you is to divide all of these by sine theta. Okay? Or I want you to take the reciprocal of all of them. Doesn't matter. Let's just divide by sine theta. I'm going to divide all of these by sine theta. That's what I'm about to do. I'm going to divide by sine theta. Or I'm going to multiply by 1 over 1 sine theta. Okay? Let's put that. That sounds more mathy and collegey. Put multiply by 1 over sine theta. And when I do that, I get cosine theta. Less than or equal to theta over sine theta. Less than or equal to 1 over cosine theta. Tell me, why did I divide everything by sine theta? So you'll know what we were doing, why we were doing this to do the proof. Why? Why did we do that? I'll lean against the wall, you think. Why?
There's no product rule when we take the derivative?
We're not going to need to take the derivative. But you're right, we did eliminate the product rule. I like that.
If you're trying to find the area of the triangle, you have to do the integral, and you don't want the 2 trig functions being multiplied by each other, divided by each other.
Yeah, it would be hard to integrate that compared to just integrating that.
Yes.
But we're not going to have to do an integral because this is part of limits long before you've learned about integrals. But at least you were thinking and listening yesterday when I talked about making them easier to do. Thank you.
Take the limit, I think 2 of them, there's a rule for it, isn't there?
Well, we got to avoid the rule because we're proving the rule. Look at what we're proving.
I know, but when you take, because you take the reciprocal of them, don't you? And then you put limit of each one.
Why would you take the reciprocal?
Was it because cosine of 0 is
Well, the one,
To
the
prove
one
it.
in the middle is the reciprocal of the...
Yeah, look what we got in the middle.
Yeah.
So if I knew the value of this, if I told you this was 0,
Is it,
Because
because
cosine of 0 is
cosine of theta is equal to 1.
that's a 1.
And
Yeah,
then
that's 1.
And then 1 over 1.
So we know 1 is going to be less than what's there. But
Yeah.
is that really what we want there? So what are we about to do? We've got to do what to all of them
Take the
first.
reciprocal.
But you're getting the idea. We've got something, see what we got in the middle? It's what we're trying to prove, or very, very close to what we're trying to prove. And then what we have on the end is something we know how to work. Since we know what this one will work out to, and we can figure out what this one will work out to, we know the one in the middle has got to be what? In between them. Is that cool? So, we're going to take the reciprocals. And this is where we've got to be careful. Reciprocals. I'm going to give, that's going to make that 1 over cosine theta. That's going to make that sine theta over theta. And that's just going to make that cosine theta. Notice I did not put the equality symbols in there. Why?
Because they switch.
They change directions, folks. Yeah, they become greater thans. Now, I'm going to explain to you why that happens over here on the side of the board, just so you'll be able to say, oh, I know why that works. Does everybody agree that 5 is greater than 2? Take the reciprocals. better do what? Change the direction of that sign, right? So, yeah, we do
That's
need,
always true.
it's always true. Pretty cool? Yeah. And that's just one of those things that is in algebra, but we never talked about it in algebra because you never needed it in algebra. But you notice we can explain it with just good old basic algebra. Now, we are now going to take the limit of each one of those because we know that this should always be greater than that, which should always be greater than that, unless the theta becomes what? 0. So, we're going to put a limit in front of all of them. We're going to write out step by step. We're not going to cheat and do it all at one time. We're going to do limit. As theta approaches 0 of 1 over cosine theta greater than or equal to limit as theta approaches 0 of sine theta over theta, which we're really excited about that because that's what we're trying to do what? Prove. Which is greater than or equal to limit as theta approaches 0 of cosine theta. Now, everybody already knows that this one equals how much? 1. I'm going to help you out too about that. This one does equal 1, but I also want you to realize that as theta gets closer to 0, who said that from the negative side? Yeah, it's going to approach 1, but it's going to approach 1 from numbers smaller than 1. Cosine's never bigger than 1, is it? See, and as you get down here, remember the cosine is the x value, right? Cosine theta, comma sine theta. As theta gets closer and closer to 0, and you move down here, your cosine is 0.9, 0.999, 0.99999. It's getting closer to what? 1. But it's getting closer to 1 from numbers that are smaller than 1. Think about this one. 1 over 0.999. This one's getting closer to 1 too. But it's not getting closer to 1 from the negative side. It's getting closer to 1 from the positive side. And if that is true, then ours is stuck in between them. Now here's the catch. If they were both getting closer to 1 from the negative side, we might have a problem because our number could be bigger than 1. See? We'd have a little problem there. But notice, this one's getting closer to 1 from bigger than 1. This is getting closer to 1 from smaller than 1. So we know that the solution to this must be a
0, 1.
1. Okay, I was in last hour when I thought, what was the name of that country?
Ukraine.
Ukraine. I asked if it was in Asia. I mean, come on, Evans. That just puts you in the stupid list, Evans. Yeah, there are stupid comments and stupid questions, and I made a stupid question on that one. That would be getting laughed out of class question when I said, is Ukraine in Europe or in Asia? Yes, sir.
Can you make me feel better?
So if you know that your theta is approaching 0, and you know that cosine of 0 right there, why do you have to, like, I guess why do you have to show that?
You just need to show that you're doing a limit.
Okay.
Because right here, if you were to actually go towards pi over 2, or get larger than pi over 2, you get different solutions. So you got to show that you're actually going towards 0. Okay? This doesn't work if you're going to pi over 2.
Right.
All right? Because then what happens is if you go to pi over 2, you're going to get approaches infinity here, and you're going to get approaches 0 here, and so you're going to find out that your answer is somewhere between 0 and infinity. So you got to let them know that you're doing theta approaches 0, a little specific step. But since we already knew what we were trying to prove, we were already looking at it here. In our brain, we were already putting a limit in front of both of those, all of those. Yeah. In our brain, we're already doing the limit. Now, this is the proof, and it has a name for what we applied. We applied a certain theorem to it. Yeah, we applied what's called the squeeze theorem. This is an application and I don't know why they call it the squeeze theorem. I would have called it I would have called it the squeeze theorem. Significant other theorem. That's what I would have called it. That way, your main squeeze, your significant other, you squeeze your significant other. I just think it'd been better if you called it application of the significant other theorem. Or you can call it application of the sandwich theorem. That's what I have to eat for lunch every day. But I would have called it application of one of those. Now, and don't think this is the only, there are hundreds and thousands of applications of squeeze theorem. This is just the first one that you ever get to see. And at some of the schools that y'all attend, you will actually be applying the squeeze theorem to other ones. All right? This is just the first one. Pretty difficult. Now, if you're thinking about, well, how would I learn this for class? Key is to learn how to make the what? Drawings. Because if you make the drawings, then you can do everything else. And the hard part, probably for the first person to ever create this and do this, was to come up with 3 relationships. Because, hey, if your relationships don't simplify down, if you find out that this is going to 2, and this is going to -2, do you really get a good answer? It's helpful, but it's not great, right? Or if you find out this one's going to 100 and this one's going to 0, then you just know your answer is what? Between what? 0 and 100. In the squeeze theorem, there are cases in physics where that's what they're looking at. They're just looking at, they know the reaction is going to either produce this much energy or this much energy, and they know that the results they get somewhere in between those two. So they make sure they can at least control that reaction. Okay? Now, they really want those two what? As close together as they can be, but in some of the physics, they're not that close. Unit circle, I just kind of think this is good for you. And this will get you through, this is going to be either a take-home question, it's going to be on some, in Calc 1 on limits, this is one of the biggies right here. There's another one we'll probably look at later next week. All right, hit